All right, so today I want to talk about one of our post-processing tools. It's called the grid generator, excuse me. And this is a feature that I don't see often. In fact, I rarely see it at all with some of our existing Particleworks users. So I just wanted to kind of bring it to the light a little bit, mention some of the details and some of the stuff that it can do, and just kind of point out how easy it is to use. If you're familiar with how to use things like the surface generator or even the mapping tool, this is just as easy as those other post-processing tools. Again, it's just something I don't necessarily see often, so I wanted to cover this topic today in our tips and tricks meeting. So we'll get started, and the first question that pops up is, what is the grid generator? The grid generator is a post-processing feature that allows Particleworks users to map out physical quantities from particles which are non-uniformly spaced to a uniformly spaced grid. The grid generator behind the scenes, it's interpolating the solution from the particles onto a fixed Cartesian grid. And if you haven't used this before, you might ask, where is this in the GUI? This is going to be located in the toolbar above the outline and projects tab, along with all the other post-processing tools. And then the next question, if it were me and I was never using it for the first time, is it easy to use? Yes, the grid generator is very easy to use. As I mentioned at the beginning of this, if you're familiar with things like the surface generator, mapping function, things like that, you'll be able to catch on to this one very, very easy. So whenever we're looking at it inside of the GUI, it's going to be right in our toolbar. And it's going to be, located in our projects and outline tab, right above it, excuse me. And just like the other post-processing tools, once we click it on the right-hand side of the GUI, the post-processing controller is going to be available, and that's where you can select a few different things to manipulate for your post-processing tools. Yep, and so by default, we have all of our objects that are selected in our scene. If we had multiple fills or multiple inflows inside of a model, some of those can be omitted, but most of the time we're looking at a single fill or a single inflow object, and so that's going to be selected for you automatically. Another thing that we can manipulate too is how many frames we want to output into either our post-processing GUI or into our CSV file. The frames, what that allows you to do, similar to the mapping and the surface, it allows you to pick, which frames in time you're wanting to particularly look at. If we have, let's say, something going on from 0 to half a second where not a lot of interesting stuff is happening, we can omit that portion of the simulation, and we can really just kind of focus on the things that are really important to us, maybe half second to a second and things like that. In Particleworks version 7.1 and beyond, this is a feature that's been improved. The Particleworks users can now select the different fields that we want to map onto the grid. So things like position, velocity, pressure, all the good stuff that can now be picked and chosen on what we see as far as in the GUI and in the CSV file. That's an option to be outputted as well. One thing that also has changed is the number of CPU cores for post-processing feature can be changed. The one thing to note though is that whatever your configuration is, how many CPU cores you have, that's going to be the maximum license it's going to pull. If you're interested in that, let us know. We can always do some testing, answer some questions, things like that. This example I did today was just a simple example, so I didn't really need too many CPU cores. It solved pretty quickly. But when we get more complicated designs, more complicated models, that might be something of interest to explore, and the multiple CPU cores for the post-processing tool may be needed to help speed up the post-processing calculation. And just again, just a few other details in the parameters. Once we select our objects, we select our frames, we select our fields, things like that, then we can kind of go in, change some of the parameters. The first one, of course, is the name You can always change that to some kind of naming nomenclature that's easier for you to recognize. And then the second one is going to be the effective radius ratio. This just specifies the interpolation radius used in the weight function as a multiplier factor of the particle size. By default, this value is going to be 2. I don't typically change this, but if you're messing with the grid generator more and more and you find you need to change that a little bit, that can be changed. And if you want to have a little bit more detail on what the actual weight function is, I would recommend to check out section 10.9 of the user manual. That I have some more additional details that we're not going to have time to cover today, and will kind of help give a little bit of light on what that weight function formula looks like. And we have the next one, which is going to be weight. This specifies, again, the weight function coefficient. Again, the default value is 2. Auto, when selected, the grid is automatically set in accordance with the particle size. You can change that off, or you can disable auto. And when you do that, you can specify the grid resolution. You can specify the number of grids you see in the X, Y, and Z direction. The one thing to note is that the grid resolution is you can only manipulate this once auto is unchecked. The other parameter is clip enabled. So when we enable this, we can specify clip minimum or clip maximums. That's pretty common, especially in our color map. We can specify minimum and max values that we want to see inside of the GUI. And the same thing can be applied here in the grid generator. And the last parameter that we can manipulate is we can enable CSV file output. If you want to export all of this post-processing information out to a CSV, just like the other ones, that can be done with the click of a button. And then whenever we're ready to go, we've got everything selected that we want to see. We simply click execute, run through the calculations, and in the GUI, you'll see that the post folder would be populated. And if you're looking in the file explorer, you'll see that post folder is populated as well. There's not really anything more complicated to using the grid generator as well. One thing I didn't put in this slide is if you want to do a little bit more practice on your own, I believe it's tutorial number 14, post-processing. It goes through all the post-processing tools, and the grid generator is one of those that's in there. So if you haven't used it and you have some interest, I would highly recommend to go back and reference that tutorial as well. And this is just some examples, or just a simple example of a gearbox that I did. Again, this was just a really small model that I did some quick calculations on, quick simulation just to get some results and some nice images here for you guys. Here, this is a grid generation that I made for this particular model. In this example, I'm looking at velocity, and I've mapped out my velocity values onto a Cartesian grid inside of Particleworks. So this particular example took me, I think maybe 10 to 20 minutes to run the actual simulation, and then maybe another maybe 2 to 5 minute max to actually complete the grid generator post-processing. So I will say, again, it's not something that's heavily used by our Particleworks users, but if there's ever interest, or you have some maybe some more desire to use this, it's very easy, and I would highly recommend to use it. So with that, that's everything I wanted to cover. If there's anything inside of this particular grid generation that you have some questions on, feel free to send the questions in the chat, or as Zach had mentioned, reach out to us on our support tickets, and we'll be glad to help you out.